All right, so I think I'm recording. Let's take a look at. We've been looking at polynomial functions. We have recently learned the rational zero theorem, and that allows us to improve our factoring skills in order to find all of the x-intercepts for higher order polynomial functions. So this polynomial function is of degree 3. I can look at it and see there's no common factor among the terms. I can look at it and see that it is written in standard form. So in order to use this rational zero theorem, I want to look at the factors of my constant term, and 12 has factors of 1, 2, 3, 4, 6, and 12. Now, fortunately, the leading coefficient is a prime number and just has the number 1 just has a factor of 1. So my list of possible rational functions is just, this was the possible numerators, the possible denominator here is 1. So each time all of these are divided by the 1, we just get that original list from the constant term back again. Alright. So now the search begins to try to find a zero of this function. I'm going to use synthetic division, but I'm also going to recognize that my original polynomial function, all of the terms are being added. So if I tried to, if I plugged in a 1 into here, there's no way that that would be 0. So I'm just going to look at the negative values in my synthetic division in my search for a 0 remainder. So I've got 1, 9, 20, and 12. And we found one right off the bat, which is sometimes rare. It seems like, that anytime that you're in a hurry or whatever, especially that the 0 is next to the last one that you try. Because, see, it is possible that we try every number in the list and none of them provide a 0, that either there are no x-intercepts for this function, or the x-intercepts that do exist are irrational numbers. See, this only tells us the rational zeros, not the irrational zeros. So now what we've discovered, that we can take this original third degree polynomial function that we did not have any kind of a method, an x method, or a factor by grouping. We didn't have any way to factor this. But now with this theorem, and using this theorem in conjunction with this synthetic division, we can now factor this. If an x-intercept is -1, if a 0 of the function is -1 in factored form, we write that as x plus 1. And now this 1, 8, and 12, well, the 12 is the constant term, the 8 is the linear term, and the 1 is the quadratic term. So it allows me, if you were to multiply these two expressions together, hey, you get that original third degree polynomial function. Well, now in this factored form, we can continue, we can find the zeros. To find the x-intercepts, you let y equal 0, and by either completing the square or quadratic formula or factoring. Sometimes factoring won't work, but here we're two numbers that multiply together to give us 12 but add together to give us 8 are 2 and 6. So here we have x-intercepts then, zeros of this function, of -1, -2, and -6. Since it was a third degree polynomial function, it can have at most 3 x-intercepts, at most 3 zeros, and so I know I have found them all. I know that there's none that are missing. So I hope that helps, and I'll talk to you later.